Hey, welcome back, and in this video we're going to deep dive further into Google Cloud Functions and look at more of the non-functional elements of this. So in particular, we're going to look underneath the covers. We're going to see what environment variables and headers and IP addresses that actually run underneath the hood in the Google Cloud Function runtime environment. So what we're going to do is send a whole bunch of traffic to our function up in the cloud, and then we're going to do some interesting things. We're going to see how it performs, how it scales up and down, see what that looks like in a dashboard. Then we're going to start crashing the application as well, right? Have a little bit of fun, see how our active instances go up and down. And then we'll actually even look at things like deployment, right? What happens to our instances when Google Cloud Functions are being deployed, right? How does it manage to keep our sites highly available? And with that, we're going to get started. So the first thing we're going to do is we're going to open up our Express application that we used in the previous video. So if you haven't seen that video before, or you don't have experience of Google Cloud Functions, if you look in the top left-hand corner or right-hand corner, I can never remember which one it is, but if you look in that corner, what you are going to see is a very detailed introduction video. But to be honest, if you understand Node.js applications already, then you'll follow along fine. But if you do want that detailed introduction, as I said, the video link appears in the top right-hand corner. Okay, so let's get started. So the first thing I'm going to do is open up VS Code. So if you look at my screen, I'm just going to type in code dot in my application, and then you will see this very simple Express web server that I created in Node.js the last time. All it does is, by default, it's just going to send back the words, hey, that's it. If I pass in the query string, the parameter message, then it's also going to return back whatever message that I pass through on the query string. So that is the simplest web server you can imagine. For that to work in Google Cloud Functions, there's a couple of things I kind of want you to be aware of. Is if you see here, you see there is a sort of dev dependency called Functions Framework. And that basically allows you to run Google Cloud Functions locally on your machine before you do a deployment. Again, it's all covered in the other video. So because I've installed that, you'll see it calls npx functions framework -- target hey. So all I'm doing in this particular case is when I type in npm run start, then what it's going to do is, rather than kicking off Node.js as normal, it's going to run my Google Cloud Function in a similar way to what it would run in Google Cloud Functions on the cloud. Okay, so let's do that quickly. So if I go back into my terminal and I type in npm run start, as I said I would, we just kick that off. You will see it is now running in localhost 8080, and we'll just expand that out. If I type in localhost 8080, you will see it has come back with hey, as I said. And as I said before, if I was to pass in a query parameter called message, and then I could put anything I want in here. So I could put in woof, and then hit return, and then it's going to return back woof. So what I'm going to do now is I'm going to deploy that up onto Google Cloud. I have pre-installed the Google Cloud Shell SDK. Again, I covered that in my other video. So that by default is on my machine already. So all I need to do to deploy that function is just type in gcloud functions deploy, and I'm going to give it, because it's the same function that we did in the last video, I'm going to give it the exact same name. So it's going to be gcp func-hello2. So next thing I need to do is specify the entry point for the function. So in this case, it is --entry-point, and I need to put the name of the function that's going to be executed whenever my web server's hit. So in this case, it was hey. So if we go back to my VS Code for a second, you can see that I'm exporting my Express application as the function hey. So it's basically whatever name I give there is what I'm going to be using as my entry point. So in this case, it's hey. I'm going to use the runtime. I'm going to set the runtime to Node.js 14 because that's the version that I'm running and it's what I want it to run. And because Google Cloud Functions can support multiple different types of Google Cloud Functions, so it can support things like HTTP servers, it can support things like Cloud Pub Sub, invocations, I'm just going to specify that I want my trigger to be HTTP. Now, to be honest, actually that is the default, but I like to specify it anyway. And then the last thing you need to do is you need to specify what the project is. So in Google Cloud, you have this concept of projects, and every function that you have has to be associated with one. In my previous video, I created a project already called Chuck Hello World Test 2. So actually, if we were to go into our console for a second, so if we go to console.cloud.google.com, that will bring up our Google Cloud dashboard. And there you can see that Chuck Hello World Test 2 project that I previously created in the other video. If you don't have a project, then you would have an empty dashboard when you do the sign up, and then you could just click on and create a new project. But as you can see, I've already got this project called Chuck Hello World Test 2 already set up. And you can see I've got GCP Func Hello 2 already up on my dashboard. So all I'm going to do is set that project to Chuck Hello World Test 2. And to be honest, if I wanted, I could change the name of this function, right? So let's, rather than calling it GCP Func Hello 2, let's call it GCP Func Hello 3, and then we can see it's going to be a different entry, and we'll have a brand new clean function there. So if I hit return, it's going to take a few minutes or so to deploy that. It's got a few questions there. So the first question it's got is, do I want to allow unauthenticated invocations? That basically means that, do I want it to be a public access? And I'm going to say yes. And then it's going to go off and do the deployment. Alrighty, so you can see that is now deployed. And if I want to test my functions work okay, I can just grab the URL from here. I will copy that, and then if I go up into my browser, I can paste that in and then hit return. And you see it's returning hey, as we did before. And then I can obviously pass in a message, whatever I want, and it's going to display. So we'll put in woof, and woof comes back. So we've deployed our application. What we're going to do now, as I said, is we're going to have a look at what happens underneath the covers. So the first thing I want to cover is this idea of high availability and self-recovery. So as you can see, at the moment, my function is running within a region, which in Google's cases is US Central. Now, Google has multiple regions throughout the world, but in this case, I'm keeping this to US Central. But I could run it in UK, I could run it in any other country, and Google has a full list of that. Now, what that does mean is my function will remain within that region. It won't go outside of the region at all. So I don't have multi-region availability, but I do have single region availability. But what Google will also do for us, it will manage the running of the underlying containers. I don't need to worry about that. So if things like my container fail, or if I need to deploy a new version of my function, then Google will manage all of the management of the containers underneath. It will manage the infrastructure, and it will be able to handle basically restarting that container and getting it deployed onto another machine. And actually even has multiple availability zones within a region. So what I mean by that is they have several data centers which are a certain space apart. And therefore, even if you lost one of these data centers or these availability zones, then there will be other data centers that are available, and Google will automatically pick up your container, your function, and it will run it in another one of these availability zones. So that gives you quite a lot of high availability, right? And all of that's handled for you. You don't need to pick it up and redeploy it or move it around. Google will handle that for you. But what it also does is it's able to handle things like deployments. So let's say I have a function and I'm going to make a change, let's say whatever I want to do there, then Google, for example, will handle the deployment of that function for me. So rather than stopping the function and then my function dying and nobody being able to access my service, what it can actually do is it will ramp up the number of instances I have. It will deploy my new function and then ramp down the old one, and then it will do a cutover from my first function to my other function. And you can, and we'll show that working, but you can kind of even see this on the dashboard. So if I go into, let's go into VS Code for a second, and then let's say I decide to add a new endpoint here. So let's say I have something called /hello, and then what I'm going to do is do a res send hello here. We'll get rid of this first line here because we don't need this. But if we have a res send hello, so now if I go /hello, it's going to return hello. And I actually come back into my terminal and we just deploy this function again. So we'll give it the exact same name. So what we're doing is we've got a new function that we're going to be deploying, or a new version, but it's going to replace the existing function that is deployed in Google Cloud. So that's going to take a couple of minutes to do that. And then what we will do is look at the dashboard underneath that and see how Google ramps up the instances and ramps down the instances to be able to manage that deployment process. Okay, so now that it's deployed, if I were to come back into this, if I hit return, you see it's still returning Wolf, and if I put in another value, you see my function's still working. But now, if I, rather than calling my default, if I do /hello, you see it's now coming back with hello. So my function is working. So what we're going to do now is we're going to open up the dashboard so we can see GCP func hello 3 there, and we'll have a look at actually what happened on the dashboard when we did that deployment. So first thing to see on my screen there, you can kind of see that it says version 2 deployed at 5.14.15, right? So that is when we ran our gcloud function deploy, right? And kind of look at this, right? So in this one here, I want you to look at invocations per second on our dashboard. So at 5:09, I made a call to via the web browser, and you can kind of see there. And then at 5:15, after the deployment happened, we made another call. And just so everybody's aware, you know, I made another call at sort of 5:23 there. So we've had 3 calls via the browser there. That's fine. So if we scroll down a little bit further, we're going to ignore execution time and memory utilization for a second. What I want you to look at here is active instances. So at 5:09, we were currently running with 1 instance. So you can see 1 instance was running. So that was the number of active instances of our function. And then look here. So at 5:16, right, we were running 2 instances. So that's roughly when I hit the browser. And why are we running 2 instances at that point? Well, because over here at 5:09, we were running the first instance, the original version 1 of our function, right? That's still there to satisfy any incoming traffic. And then what happens is we've deployed version 2. So what Google does is it leaves version 1 running, and then it spins up another version, which is version 2. So both version 1 and version 2 of our function are running at the same time. Yeah. And then what it does is it redirects traffic, incoming traffic, to our new version, version 2. But version 1 is still running. And then later on, what it will do is spin down the original container, the original function. And we see that here. So if we look at now, we're now back to running. So this was logged at 5:24. So you see at 5:24, we were running 1 instance of our container. So you can see in between that time, between 5:15 and 5:24, it eventually said, okay, my new version 2 of my function is running fine. I don't need to run the original version 1 anymore. And then it just spins down the old version, and all traffic is now going to version 2. So that's how it does deployments. So and that means that you get high availability. So if you're deploying a new function, it means that your system as a whole, your service as a whole, isn't going down. The old function is there, it's running, and it's running in parallel to the new function that you've deployed, and then it moves all the traffic across to this new function. And once all traffic is handled by the new function and we know that it's working well, then Google spins that down and the new function takes over. So that's kind of cool, right? So that means that this is not something I have to manage myself, whether even in Kubernetes and I'm using rollout deployments, etc. That is all handled under the hood, and that sort of maintains that level of high availability. And even if I go back years before, right, we were deploying services manually ourselves, then you would have to sort of time things and move things around, right? All of that is fully automated and handled by Google. As I said before, what we want to do is get underneath the covers and actually see what's going on in the cloud with Google Cloud Functions. So to do that, what we really want to be able to get access to is things like anything that's passed in the headers, the environment variables, or even things like the IP address. And then we can use that, especially when we're starting to do things like crash the application and see what goes on underneath. So the first thing I want to get access to is the environment variables. So I will just like the same way as we did before, is if we pass in env as a query string parameter, then what we will do is return whatever environment variables that are running in the container at that time. So to access that, we're just going to call process.env, and then that'll get displayed to the screen. The next thing that we want to get access to is whatever headers are in our Express application, whatever's passed through from Google. So to do that, we will just modify this and we'll write request.query.headers. So to do that, all we need to do is do a json.stringify and then pass in rec.headers, and that will return that. And actually, even before we sort of go any further, if I just come back to my console for a second, if we hit npm start and then we go to our local machine, you can kind of see that if I just hit localhost 80 here, it's saying hey, as we did before. But if I put in env equals true, it's going to come back with all the environment variables associated with my machine. Again, I'm not going to go into details what's going on in my machine, because actually what we're interested in is what's going underneath the hood in Google Cloud Functions. So we'll do that when we deploy to the cloud. But just to prove that headers is working as well, if I type in headers equals true, you see it's coming back with my connection, you can see my user agent, you can see my host name, etc. So again, we will look at that when we deploy to Google Cloud. Now, there are two other things I want to be able to do. So the next thing I want to be able to do is have access to the IP address. So by having access to the IP address, I'm going to be able to tell that when we crash the application or when we scale up and down, where it's running or whether I've got a different instance of my container. So to do that, what I need to do is just kill this for a second, and I need to create a new dependency. So I'm going to use a package called public-ip. So I'll just npm install that, and we'll save that into my package JSON. So that'll take a second or two to run. And then if I go to my VS Code and we look at the package JSON, you will see I've got this public IP package now installed. Now that that's installed, what we'll do is we'll just declare that at the top there. So const public IP equals require public IP. And then what I want to do is grab the IP address on startup. So we'll do that as an async function. So we'll just start this up. And what we'll do is we'll capture the IP4 address and the IP6 address. So we'll just do an await public IP dot v4. I'll capture the IP6 as well. So IP6 equals await public IP dot v6. That's fine. Next thing I need to do is just declare my variables so that I can access them a bit later on in my app. So we'll do that. And then obviously I need to call this function as well. And now what I'm going to do is just very quickly, let's copy this, is send the IP4 and the IP6 addresses whenever I ask for them. So we'll just put request query IP4, and then we will send IP4 back. And then similarly, we will do the same for IP6. So we just made that change. We'll change IP4 to IP6 and change IP4 to IP6. If I restart my application, so if we do an npm run start, and then we go back into my browser, you'll see my machine is still working, which is good. And now if I change that to IP4 equals true, it's returning my IP address. So that's working fine. Now, the last thing I want to do before I deploy to Google Cloud is it would be cool in the same way as when we did a deploy and we saw the scale up and down, it'd be cool to see Google recover our functions or recover the containers automatically underneath. So the nice way of doing that is rather than sitting around waiting for it to crash is I'll just make it crash. So how we're going to do that is we will go back into VS Code and we'll add one more query string check. And this time we're going to look for whether it says crash. So we'll just put crash. And then what we'll do in that case is rather than sending anything, we're going to do a process.exit. So that will just kill the process underneath that. And again, if I come back into here, so if I do an npm run start, and you can see it's returning the IP4 again, but this time, if I change IP4 to being crash equals true, help if I can type, and then you see it's exited, and then you see it's killed my application there. So that is our application built. So what we're going to now do is just get that deployed across to Google Cloud, and then we'll see what's happening underneath the hood. So to do that, what we're going to do is just call our Google Cloud function deploy. I'm going to be lazy. I'm just going to do another run over here. So I've just pulled it from the history of my shell. So we'll just click that, and then it will take a couple of minutes to get deployed. Alrighty, now that that's deployed, what we can do is just grab the URL from our console there. And then if we just bring up our browser once again, and just test it works for a second. So we'll just click here and you'll see it's returning hello 3. And again, if I put in message like it did before, it will say woof. So that works okay. And of course, if I put in hello, then that should work as well. And it says hello. Now, what we're going to do is just have a look underneath the hood and have a look at some of those headers and environment variables that we've seen. So first thing is let's pass in env equals true, and then we'll see what environment variables are there. Okay, so this is pretty cool stuff actually. So I don't know what half of these mean, by the way, but but what you can see is it tells you as an environment variable, it says what the function target is. That's kind of cool. I don't know what GCF block runtime is, but there we go. You can kind of see where Node.js is installed or where its node path is. So you see workspace, node modules. So that's kind of interesting that the working directory that we're in is in workspace. That's kind of cool. You see the node env environment variables is set to production. The home folder is /root. You can see this Debian front end. So actually there's something really interesting that we know therefore. Underneath the hood here is a Debian operating system that's powering this container. It's probably Google distroless. That would be my guess. Other interesting things is it's running port 8080. You see the service name is funchello3. We've done a few deployments already, and you can kind of see here it says k_revision is 4, so it's tracking the version of the function as well. You see the runtime's Node.js 14. You see it's HTTP, and then there's all the kind of path variable. So that's kind of cool. We've learned something about Google Cloud Functions. We know it runs in a container, and we know that it's a Debian operating system underneath, and it's probably Google distroless. Now, the other thing that we passed in was headers. Let's have a look at this. So headers equals true, and that's pretty cool stuff. So in the request headers, you're getting things like the host. So there's US Central Chuck Hello World 2 .cloudfunctions.net. Interesting. You're seeing things like the user agent. So that's all the stuff that I'm passed through. There's some really interesting stuff that's being passed through here. For example, so you can kind of see it's passing through my IP address. It's passing through the lat and longitude of where I live. You can see my my broadband's being provided in Ipswich, so please don't be creepy, people. Don't go and try and find me or whatever. So the next thing that I passed through as well was I passed through IP4. So let's call that, and there's the IP address. So we know this is running on 107.178.232.173, and that's going to be useful for when we crash the application, which we're going to do in a second. When we crash the application, what I'm hoping to see is that my application dies. I'm hoping that Google is going to automatically recover that, which I would expect. And I would also expect next time I hit this address to see a new IP address allocated. So let's do that now. Let's change IP4 to crash equals true. And we'll just run that. And we get this error, could not handle the request. So that has been crashed now. That's cool. And then if I go back and we run GCP hello 3, you see it's back up and running. So I'm getting the hey. And again, if I put in IP4 equals true, I should be getting the IP address. And lo and behold, I'm now seeing a different IP address. So Google has automatically, under the covers, taken my application. Even though it's crashed, it's dealt with it underneath the hood, spun me up a new container, and then served up the request again. And I didn't have to do anything underneath that. And you can see that it's got a new IP address associated with that. Alrighty, so what we're going to do now is we're going to have a look at our function in the dashboard and then see what happened when we crashed it. So we'll just click on funchello3. Interestingly, as you can see, we're running version 4. That was the version we deployed at 6 p.m. And if you remember when we looked at the environment variables, or it could have been headers, I can't remember. But remember I pointed out that it said it was running version 4, and there you go, it's corresponding to what was passed through there. So there's a correlation between the version that's deployed and on the container and what is displayed in the dashboard here. So let's have a look at the invocations per second here. So you can kind of see that it's running okay at this point, but let's come down here, and this is probably the interesting part. So there we go. Really super interesting. Remember, we deployed this at around 6 o'clock, right? So remember earlier in this video, it said at 5:23 we were running at one instance because we deployed at 5:16. It went down to one instance, and then sure enough, when I deployed it at 6 p.m. there, you can see it's went back up to 2 instances to handle that deployment, just like it did before. But then if you look here, it's at 6:04, it's went back down into one instance, so it scaled itself back down. And then we were clicking around, if you remember, and then I hit my crash function, and look, it's scaled down to 0. So I crashed it. There was nothing running at that point. But good old Google, underneath the hood, automatically just restarted that container. So I lost access to my service for a couple of seconds. But it recovered it almost straight away, and the users underneath didn't see anything because Google's just fired it back up. But there was a brief period of time where it wasn't running. Now, I guess what you could do is increase the number of instances that you've got and maintain a minimum amount, but I wouldn't bother because Google is handling this underneath the hood. But as you can kind of see, we crashed it, it died, and it automatically recovered there. Okay, so that's what happened in our dashboard, which is kind of cool. What we're going to do now is we're going to have a look at how Google starts handling once there's a bit of load. So what we're going to do is we're going to just start throwing some load at our service, and then we'll have a look at the dashboard and see how it's responding and what happens when we crash things as well. So this is going to be a little bit of fun. To do that, the first thing I'm going to do is we are going to go back to my machine for a second. We'll just clear our console, and we're going to use a performance testing tool, which is for free. And if you're running a Mac, it should be installed automatically. If not, you can go and download it. It's called Apache Bench. So what to do to performance tests with Apache Bench is you just type in AB, so it's which stands for Apache Bench. We're going to send through, so -n 1000, we're going to send through 1,000 requests over a period of time, and we're going to send that to a URL. So I'm just going to pick one of the URLs that we had here. I'm just going to copy and paste it. I think we'll make it do a little bit of work. So I'm going to send it to the IP address URL. So we'll paste that in there. And the last thing I need to do is I forgot to set the number of concurrent connections. So in order to test scaling, you can tell Apache Bench to run a concurrent number of connections. So we're going to set it to 10. So that will be sort of 10 instances pinging at the same time to this one IP address. And then if I hit return, then it will start running these requests. Now, if I come back, so we'll just give it a second. You see it's done 100 requests already. If I come back to my browser for a second, let's see what's going on there. So I'm still getting IP address 12, but look, I've got a new IP address return back. It's 149. And let's refresh again. I've got 181. Refresh again, 149, 149, 149, and then 229. So my requests are getting clearly distributed across a bunch of instances at the moment. It's done 800 of these. So we know for a fact that there is more than 3 or 4 instances running in the back end, because we saw these different IP addresses being returned. So that is now being completed. And what we can do now is we can go and have a look at the dashboard and see how Google automatically scaled up and down our instances to cope with the demand. Alrighty, now that we've run that test, let's have a look at how Google was handling that test underneath the covers there. So if we just kind of scroll down there for a second, and we're going to take a look at our active instances. So actually, before we do that, let's just look at the invocations per second. So first thing I kind of want you to see is the 616 when we ran that test, which was a little while ago. You can kind of see our invocations per second spiked, right? It started, suddenly we were like sort of 16.77 invocations per second on average. So we really just hit it very, very fast and hard. But that's okay. It handled the traffic, right? Google just handled it straight away. There was no problem. It was just like, yeah, you're sending me a load of traffic. I'm not going to fail this. I'm just going to start responded. But have a look here what happened. Very quickly, Google really spun up the number of instances super quickly. So at 6:15 we were running 1 instance, and then very quickly we were running 17 instances at 6:16. So it automatically just went, whoa, there's a load of traffic that's coming in, and it just scaled up the number of instances to handle that. And then of course, once it was done, it just started scaling down that traffic. So those instances. So at 6:18 you see it's running 3 instances. And then, of course, 6:20, it actually scaled itself back down to 0, so because it was getting no traffic. So that's kind of cool. Google automatically scales and handles that traffic, and that's great, right? Because you don't need to worry about that. I guess there is a risk involved in this as well, right? Which is, and I think that risk is going to be that if it can scale instances automatically like that, then we could be in a situation where we're making ourselves a little bit subject to denial of service attacks, right? You saw what I sent. I sent, 1,000 requests with 10 concurrent connections, and we scaled up to 20 instances. You know what? If somebody just left that running against something that was a Google Cloud function, we could get a very expensive hosting bill quite quickly, because it's just constantly going to be responding and scaling up a bunch of instances that maybe is 20s or 17 instances is a lot. So what we're going to do now is we're going to redeploy the function, but this time we're going to limit the number of instances that Google can scale to. And we do that by setting the max instances value. So if we just set the parameter as -- max instances, and we set that, let's put it to 3 so it doesn't go over the top, so we can scale up, handle that, but scale down, but we're never going to get to like crazy 17 values. So we'll just return that. That will go and do that deployment. It'll take a few minutes, and once that's deployed, we will then run that same test that we ran 2 seconds ago and run 1,000 requests, and then see what happened underneath the hood there. Alrighty, now that that's deployed, we can grab that very quickly, and we can just test that our application is running. So if we just paste that in, it's returning hey, and then we can just check the IP address. So we'll set IP4 equals true, And then, of course, that's returning the IP address. That's fine. Let's run that test again. So what we're going to do is we'll just run our Apache bench, and we're going to send through another 1,000 requests, 10 concurrent connections, and then we will see what happens within the dashboard. So our benchmarking is kicked off again. So it's done 100 requests. If I hit refresh again, you see it's switching between 21 and 39. Nothing else is appearing, so I think it's probably doing a pretty good job of limiting. But once that test is finished, we'll go and have a look at the dashboard again, and we'll see what happens with the max instances and see if actually Google did keep to that. Alrighty, so the test is complete now, which is cool. But actually, what I think would be a lot of fun is, because it's going to take a few minutes for the dashboard to get updated so that we can see what happened. By my clock, it's sort of 6:30 at the moment. So what we're going to do now is we're going to run the same test again. But this time, what we're going to do is we're going to crash our application like we did before. So remember, we did the crash equals true, and then it killed the application. And then if we run it again, Google automatically recovered it. You can kind of see that with the IP address. What we're going to do now, though, is we're going to run our Apache bench again, but we're going to randomly just keep crashing it, and then we're going to see what happens in the dashboard when that happens. So let's come back into this. We're going to run Apache bench. So it's off running. You can kind of see 21 is happening there, but let's start just start killing containers. Kill container. You see we've got a new IP address, 208, and I'm going to crash it again. 208, I obviously crashed the other one, so that's fine. Let me run the crash a few times. Crash, 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 crash. Refresh on 199, crash, 21, crash, 21, crash, 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 217. You know, and our test is complete now. Alrighty, so we've ran these two tests. Let's go back into our dashboard now and just see what happened underneath the hood in both cases now that we've set our max instances to 3. So I'm going to open up Funkhello 3 here. And I want you to kind of take a look at this. So remember, I ran the first test around sort of 6:30, and then I ran the second test afterwards. So if we look at the invocations per second, you're going to see there the, you know, as before, I'm running there's around sort of 11 requests per second coming in at that perspective. So this was the first test I was running. And then the second test is taking about 14 requests per second. So there are my two tests there. And you can kind of see this, after I ran the first test, the invocations per second went down, but then I ran my second test fairly quickly after. Let's have a look at what's going on in the, and actually it's probably quite interesting there. Remember, I was crashing the application and I was just hitting it like crazy. And there you go. I was actually crashing around 0.28 per second at one point. So, you know, you can see crashing appears on this. So let's have a look at the active instances. And that's probably the interesting thing. So there was my original test, if you remember, where it scaled up to 17. But this time, as we would expect, when I ran my test, we never went beyond 3 instances. So Google is managing the number of instances. So even though I'm getting the same amount of requests coming through, right, I was still sending 1,000 requests in the same period of time, rather than Google scaling up to a crazy number like 17, it kept the number to 3. And therefore, I wasn't sort of paying the extra costs of having all of these containers running in parallel. And those 3 containers handled those requests perfectly, and we'll talk about that in a second. Then, of course, once the 3 containers were done, right, and once my test was over, it actually scaled down again, and we went back down to 1. And then, of course, I ran my second test where I was crashing it lots, and again, same thing. It was running 3 instances at once. You see, it's not scaled down yet, but that will scale down in a couple of minutes, and then it'll be back down into 1 instance again. So I think the lesson that I think we probably all need to learn there is that although you cannot set the max instances, I think it's highly advisable for you to set the max instances to a reasonable value, something that you're comfortable paying the cost of, right? And the way you do that is having to think about what your kind of maximum requests per second would be in performance testing, maybe using something like Apache Bench that I use to see what your service can handle. And then once you've done a test with that, or you can use other tools like JMeter or something like that. But then once you have an idea of what your services can handle, set a limit, right? Just set a limit on the max number of instances so you don't get into this crazy situation where Google is just picking large numbers and scaling up the traffic at once, right? I mean, of course, you can do that, but I think that could be an expensive way of running your solutions. Now, if I was to come back for a second into the test and have a look at Apache Bench for a second, if you remember the first test that we run earlier, you can kind of see we ran 1,000 requests. And if we look at the results for this, you see it was running around a 24 requests per second. And then the time per request was about basically 400 milliseconds, and there's another 40 milliseconds there for that concurrency. So there was 95 fail requests there, which is sort of fine. If we then look at the second test that we ran where we had limited it, again, it's the same sort of numbers, 427, 42. There's 1,000 requests, and it took about sort of 42 seconds to run. So even though I'm running, and then the last one where I was crashing things, again, about 43 seconds, there was a lot of failed requests there, right? 646 failed requests, right? And that's because I was just going crazy and killing it all the time. So Google was trying to handle the requests, but I was sitting killing all my instances underneath. But that's sort of fine. You would sort of expect some fail requests in those scenarios. But I think the thing that I'm sort of trying to get across there is that Google is handling the failed requests underneath the hood for you. Of course, when I was going click, 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 we were probably killing more than the 3 instances we had available, hence the number of failures. But that's okay. But and the Apache Bench tool retries like other people would. So I think the key to this is that whether I was running 3 instances or I was running 17 instances, actually it performed about the same. And as you see, Google underneath the hood was handling the failed requests and me killing the containers, and it would spin up new containers. So I think, imagine if I had to run that infrastructure myself. It gets quite complicated. So it's really nice that actually I can just offload all of that to Google to handle. But again, the lesson in this one is obviously set your max instances to a reasonable value. Now, probably the other question you're probably thinking to yourself is what if I set max instances to 1? I could set that if you wanted, but I think it's going to be fairly obvious what happens, which was I'll maintain 1 container when I'm doing my bench test, but that's cool and all that. But when I start killing it, I'm going to get a loss of service. And actually, I think I'm going to get a loss of service when I do my deployments. In fact, there's probably an easy way of testing this. So let's switch max instances to 1. So we'll do that deployment, and then we'll see what happens underneath the hood. And we'll probably what we'll do is we'll do a deployment, and then we'll do a second deployment. Okay, I've done my first deployment, and if I just very quickly call my application again and hit refresh, you can see it's working again and it's returning me an IP address. What I'm going to do is do a second deployment, and then that will allow us to see what happens with the deployment when we set our max instances to 1. The key thing is Google going to maintain, ramp us up to 2 instances, so it ramps one up and then ramps the other one back down, or are we going to get a loss of service? And actually, I don't know the answer to this. We're going to find out together in about 2 seconds, but let's see. So it's going to do that deployment, and then we'll have a look at the dashboard and see what the result is. Okay, so the function has been deployed for second time now. You see the version is version 7. So we'll go and check that out in a minute or two. But before we go and look at the dashboards, because it takes a few minutes to update, I think what would be really cool is to actually see what happens if we run an Apache bench test and run 1,000 requests at once, 10 requests per second at our service. Let's see what happens. We'll run it once as normal, and then we'll run it a second time where I start crashing it like crazy. So let's see what happens. So let's run Apache Bench. We're going to hit the IP4 thing again. So if I start hitting refresh, you see I'm at 227 now. So the good news is I'm hitting request lots here, but nothing's happening, right? There's no other IP addresses coming back, which is cool, right? It is staying on 227, which is great. No other instances is being spun up or spun down. So we know that Google is respecting our max instances. But what you can see now is we're on 700 requests. And I guess what we'll do is once that test is finished, we'll have a look at how long it took to execute that test. Was it running at the same speed? Was there any performance differences? Let's see. So actually there is. You can kind of see it took 49 seconds there. It's had 1,000 complete requests. There's had no failures, which is good. And it's performed at sort of 20 requests per second. And you see 491 and 49. So what is that meaning? Well, actually, it's handled the load okay, which is fine, but it's obviously getting requests at a higher rate than it can handle. So it's taking a little bit longer. It's queuing up those requests, and then the thread is obviously getting to it and then responding. But you see that reflected. We're running at this sort of 49 milliseconds across all the requests. It's taken 49 seconds to do those requests. But if you remember, if we scroll back up, you see on the other tests, it was doing that a little bit faster. So in previous tests, it was basically doing it in 42 seconds. So there's 7 seconds of a difference there. And you see where it was 49 milliseconds on average before, it's now, on our test, it was 42 at that point. So I think that's just something to be aware of. You could be super limiting and bring it down to one instance, but you're probably harming yourself. You're certainly making it slower, right? So if you get a barrage of traffic there, that one instance is just going to get slower and slower and slower. All right, so what we're going to do now is we're going to run our test, and this time we're going to start crashing it randomly like we did before. So we're going to just run the test, 1,000 requests over 10 concurrent requests. So this time we are going to hit our crash. So we'll just keep crashing it a few times random. So I'll hit refresh, refresh. It's come back with 156. Let's crash it again. It's got a new IP address. Let's crash it again. Got a new IP address again. Let's crash it again. Let's crash it again. Let's crash it again. And then let's see how it handles. Yep, 167. We'll crash it again. We'll refresh. It's handling that fine. So Google underneath the hood is obviously handling the restarts as we did before. But I imagine what's going to happen is when we look at the results that we've got there, it's going to probably even take even longer than the 49 seconds that it did before, because it's obviously got to keep restarting these container instances. So let's have a look at that. And yeah, it's exactly what I said there, right? Which is it took 60 seconds there. We've got concurrency of 10. There was a lot of failed requests, so it had to do quite a few retries. So it took a lot longer to do that. But of course, there's going to be more waiting time, right? Because guess what? It's going to wait until the containers start, and then it can serve those requests again. So it's had a bit of an impact there with all of these failures. So that's kind of it. So I would say, and we'll have a look at the dashboard in a second, and we'll see what happened with all those failed requests. But I would say, obviously, having your max instances to 1 is probably not a great idea. Okay, while we're waiting for that one to update, let's have a look at some of the earlier tests on the dashboard and see what happened there. So I'm going to come back into our dashboard. Let's just... So I'm going to come back into our dashboard. So we'll click on GCP Func Hello 3. And we'll have a look and see if the dashboards have been updated. So there was the first test we ran. So that was a sort of 650 there. This was with our max instance set to 1. So that's kind of okay. We were running at sort of 13 requests per second. 647 is roughly when we did the deployment. So we've got that sort of one test that I did there, and it was running fine. So it's obviously doing 1. Let's have a look at the active instances. So good news there is actually between 648 and 651, we've maintained 1 active instance. So for whatever reason, Google has managed. Remember, I did the original kind of deployment. So Google has done that deployment. It did it at sort of 648, but it never did that scale up and scale down thing. Remember in the previous deployments, we scaled up to 2 and then back down again. It didn't sort of do that there. There's a sort of blankness there. So probably I think what's going to happen is during that deployment there, it's probably you've probably lost your service, and maybe there's a way of testing that. So if we come back here for a second, let's do another deploy, and then let's see whilst that's deploying, let's see if we can access our service. So let's put in hello. So our service is obviously still up at the moment, so it's kind of doing that deployment. So it's obviously still up and running, which is good. It's just not doing this sort of scale up, scale down that it did before. But it seems to be maintaining the service. So if I go message equals woof, yeah, it's all kind of working. It's deploying. There may be a point where let's see if we can get the IP address back as well. There may be a point where it becomes available for a second when it does the switch over, but sort of looking okay at the moment. Still deploying. We're on IP7 at the moment. There we go. It's just done the switch to 209. And then it's fine. So it's not done this sort of scale up, scale down thing, but to be honest, it's not harmed your service at all there, to be honest. So again, it's not something I would be necessarily worrying about. Let's go back again to our dashboards, and then what we're going to do this time is have a look and see what happened in our second test when we were failing the instances lots of times. So good news is our second test is recorded in invocations per second. So you see that there, around 16 invocations per second. And then let's have a look at the active instances. Again, nothing exciting's going on there, right? It's maintained active instances as 1. So of course it's sort of spinning up these instances up and down as the test is going on. Which is fine, and you can kind of see we've got this sort of crash rate of 0.18 per second, but it's maintained sort of active instances as 1. So we've not had an overly scary loss of service there. It's not like instances have just shut down out of nowhere. So but what I would say there is obviously keeping your max instances to 1 is not a great idea, because you've still got that slight delay when Google has to recover the containers. Whereas if you've got max instances set to a higher value, you're going to have a more available service. So there we go. I think we finished this video now. Just to kind of summarize, the Google Cloud Functions is a really, really powerful solution and service. The thing I like about it the most is that it handles everything underneath for you. I mean, in this video, we have scaled up and down, we've killed our service, we've ran loaded it, and we've seen how Google Cloud has handled this, right? And the key things from this is stuff that you would need to be manually doing yourself if it wasn't a serverless solution. You would have to be setting the number of instances, you'd be running clusters, etc., and you'd have to pay for the cost of those clusters. You don't need to worry about any of that because you're only paying for the instances that you're using, right? And the amount of compute time that you are using. So you can get yourself a really scalable service that can scale up to a massive load. If somebody suddenly hits you with a lot of requests at once, then you will automatically scale up to that, or Google will scale up that for you, handle that load, and then scale back down. So if you're running something that's a really peaky service, maybe it's like a World Cup final, or maybe it's like a graduation day or results day, or maybe you get a lot of traffic between 5 p.m. and 6 p.m., then you're not going to be running a cluster to handle all of those requests, right? And have capacity sitting waiting to be used and you paying for that. You're only paying for what you use at that point. You still have that capacity available to you, but you're not managing any of that. That's all handled under the hood by Google. And then similarly, it handles all the resiliency there. So if your service crashes or if there's a data center failure or something, then it'll automatically recover. There might be a slight teeny tiny loss for a second, but it's going to switch over and it's all going to be handled. So I think in whole, I think Google Cloud Functions, function as a service is a really great solution, low cost. And if you're running Node.js type applications, it's really a great option for you. Now, in a future video, we'll look at things like Google Cloud Run. And the reason I'm going to look at that one is because you get a little bit more control of things at the container level. Whereas, of course, with Google Cloud Functions, you're kind of restricted to running express services in that case. So if you're wanting to do something a bit different, maybe you're wanting to run something like Fastify or something like that, or maybe you've got other things you want to run in your containers, or if you want to have a really portable container that you can run multi-cloud and not be kind of hooked into to Google in that sense, even though I don't think there's a lot of lock-in here. It's how I'd write applications anyway. Then Google Cloud Run is probably a great option, and actually it gives you a bit more control in some of the deployment stuff as well. So we'll cover that in another video. But anyway, hope you've enjoyed this video. Hope you've sort of understood some of the non-functional elements and it's made a lot of sense to you. And we'll speak in the next video.